Welcome. We will start up now for this webinar on new solutions in district heating, and we're going to hear some presentations taking you through some of the very exciting and new technologies that can help utilities and district heating companies, utilities to be more efficient and help them into a more complex world, because we're moving from a more simple district heating world where we have maybe one production site to have mutual and many production sites. The whole system becomes more complex, and also we have technologies that can help us to have more efficient solutions. So this is what we're gonna hear about today. Thank you very much for signing up. We have about 100 been signing up for the webinar, and I've looked into different nations. There were 27 nations, different nations been signing up. So it's a very diverse group of participants. We have a good mix of utilities, consultancy companies, people from cities, also technology companies. So we have a good mix of the whole value chain within district energy. So welcome to this webinar. I will just show you short the program of today, and then we will go ahead from there. I will share my screen, and I hope you're able to see it in a few seconds. Here we are. And full screen. So what we are showing today, or discussing today, is some solutions, what we call end-to-end solutions to achieve the green transition within district energy. And the program of today is we have a presentation on end-to-end approach to optimize your district energy networks. We have Lars Troldahl with us from Danfoss. A second presentation is there are actually three persons involved in it. It's how to gain operational and energy cost savings in the entire district energy value chain. And then we're going to have a case study from, I'm sorry if I'm not pronouncing it correctly, Laurie. We are going to have, you're going to have a presentation about from Vatajankoski in Finland about real life case of district heating. Where we talk about what their experiences with these end-to-end solutions and automation solutions. Then we have a Danish utility from Fjernvarme Fyn, one of the larger district heating utilities in Denmark, where we have Per Andersen with us, and he will talk about some considerations about online modeling and how they consider to use this. And then we will have questions and debate in the end of the program. And I just want to mention that you're more than welcome to raise your hands, and we will, and so we can give the microphone to you, or you're also very much welcome to ask questions out in the chat function, and we will answer them as we go along. I think this was the words from me for beginning, and then I will give the word to Lars Troldahl from Danfoss. And please raise your hand again if there are questions. Lars, will you take it from here?
Yes, thank you very much. Do you see my screen? Just a reality check here.
Yes, we do.
Good. Thank you very much. But thank you very much for all the people signing up for this webinar. So we will try to dive into end-to-end solution to achieve a green transition under that umbrella. And we will start a little in the bigger perspective here. So we are looking into these global mega trends that are transforming our world, and also when we talk about the district energy. So we see, of course, like in a lot of industries, digitalization is really taking on electrification, climate changes, food supply, and urbanization. And all these things, they are playing into our agenda, working with district energy. For those of you who know Danfoss or don't know, so to mitigate these mega trends, something like a year ago, a new business unit were formed within Danfoss to put together people with the skills and the experience and knowledge from various divisions, and which is now under Danfoss Climate Solutions. So when we're talking about district energy solutions, we are a part of Danfoss Climate Solutions, and the aim of this is to be capable of delivering end-to-end applications to our customers. So we have received back in 2019, Aalborg University, they conducted a study to look into how this European decarbonization, how these goals, how can they be reached by 2050 by combining energy efficiency with the integration. So you can also call it sector coupling. And they said that the CO2 neutral city starts with district energy. And some of the takeaways from that survey can be seen here on the screen, but we are talking about big numbers, big savings potentials, if we in conjunction all do this the right way. So by integrating systems in a more cost-efficient way, a lot of money can be gained in reduction of energy consumption. Also, by implementing low temperature district heating, that will also bring down significantly the energy savings. One of the things that also came out of this study is that if these are, which we also believe it is, ambitious goals to reach these in 2050, they come up that quite some new district heating systems will have to be built, and actually even before 2035. So also something to gain from that. Also by using a system approach and optimize where we can with the solutions, up to 30% of the space heating demand can actually be obtained here. And also going from a demand-driven to a more system-driven approach can help to harvest some energy savings. So a lot of potential, but also a lot of work to do to reach these goals. If we look graphical on how district energy is evolving, we see more and more heat sources actually being attached to the systems. We see from waste to energy, cogeneration, thermal heat storage, you name it, and renewable energy, and also waste heat. But more and more sources are being added to the system, and that is also to obtain, I would say, the green agenda. So going from black energy to greener energy, and this is a part of the road on that journey. Some of the tendencies that we are seeing driving this is, as I already touched a little upon, that we see a shift from a single source to multi-source, as you also saw on the previous slide. And we also see a tendency in a shift from fossil fuels to renewables and surplus energy. And also, a little depending on where you are in the world also, but we're also starting to see a shift from high temperature district heating to low temperature district heating. So quite some changes are happening within district energy. So with these mega trends and evolution within district energy, we did actually a couple of years ago ask our customers, our ecosystem, about what challenges do they see in district energy, both here and now, but also in the future. And all this input, which came across countries all over the world and different sizes of utilities, partners, ecosystems, all that information were actually taken back, and we came out with these 8 key challenges within district energy. And actually, we took these challenges back again and revisited the ecosystem and asked if they could recognize that these are some of high on the agenda challenges within district energy. And the answer was pretty much yes. Not a big surprise, delta T optimization is pretty high on the agenda. So all that can be done to optimize on delta C to make sure that you reach the economical balance between temperature and flow that's pretty much all over. That's where you really would like to optimize. Also, when we talk about optimal network design, both when it comes to existing networks where you will extend it, but also building new networks, of course, you would like to do it in the best possible way, also having all the new technologies, taking that into consideration. And decentralization, as we have seen more heating supply sources are coming into the game here, and of course that increases the complexity. But ways to actually to overcome this are also seen as very important to on this journey. And decarbonization, which is, I would say, of course, from political side and legislation, is something that we all have to look into and be compliant to these, or even maybe even be ahead of what is required or expected of us. Also very high on the list is peak energy demand. So what can be done to avoid that in peak periods that we should limit the use of the most expensive heat sources, could be gas or fuel. So that's also something that, of course, everybody would like to address in the best possible way. What is here called legacy SCADA is actually, we will get into that also when we talk about lean heat monitor, but there's a big, more and more data is obviously in play, and a way to use that is obvious that it should be fairly easy to integrate this. So it should not be difficult and time consuming to add on new devices which can deliver data. So modern SCADA solutions or newer technology is also some of the things that are being asked for. Then what we call here increased focus on business models. That is actually in order to make sure that the customers, the consumers, will also take on some of these new solutions, technologies. There is a big ask for say, how can we accelerate this? And that can be by that utilities are renting out units, or it can be leased, or there are various ways to do this to incent the consumers actually to also on the secondary side to optimize the full chain here. When we talk about resilience, COVID-19 is quite good example of that actually. So this survey it was conducted before then, but a quick change in the demand. Are the system actually built, and are they robust enough to accommodate this? And from a district energy perspective, I think we all can be pretty happy and see that it's very few cases we have heard that it was actually not possible to accommodate this huge shift that people at work from home, and weekend demand patterns actually became weekday patterns, etc. So a way to make sure that the systems are really resilient to help. That's also one of the 8 things here. So Lars, you have to help me to if I should speed up the exercise here.
Well, 2 minutes more.
Okay, so I will do it quickly. 20%, 25% of the world's CO2 emission, it's related to heat production. So a lot of potential here that we can help. And that can either be perceived by you take one burning need and address that and work on that case by case, but you can also take the more holistic approach and look into it from an end-to-end perspective. That's why we're here today also to discuss this. I will just skip this one. You will get the slides after, but shortly mentioned. So what is required, what we are being told is that it should be modular, the solution we are providing. It should be open, it should be secure, and the possibility of having both hardware and software from one vendor is in some cases also something that is asked. I will skip the video. We can send that afterwards. It's just an illustration of what have been told. Or do you allow me to do that, Lars, or what? Or well, we will skip it. So if we translate this into some product groups that we will look into today, is that we distinguish of course, between the primary side and the secondary side, but we have solutions that accommodate both sides. So we will dig into this shortly. Lean hit production on the production side, lean hit network on the distribution, lean hit monitor also on the border between distribution and the demand side, and we have lean hit building on the secondary side. We will have these solutions more. This is pretty much the same as before, just with a little more words on it, and we'll get back to that shortly. Having talked about holistic solutions, and it should be integrated, so it's important for us to emphasize also that we don't see software as something alone, or components, hardware, and something alone. We see it that integration should be both what we could call horizontal integration between software solutions, but obviously we should also integrate and get data from all the sources we can from the component and hardware side. Could be substations, could be heat meters, it could be anything pretty much, and from all kind of vendors. Finally, if we look into this, so what are we actually talking about should be obtained by an end-to-end solution. On the demand side, we would like to be able to predict and optimize on this. On the distribution side, we would like to design and operate with the best possible optimal thermohydraulic solution. And on the production side, of course, we would like to select the right sources with the best possible economy. That's pretty much what are being asked. And this pretty much concludes this first part.
Lars, thank you so much for this more overview of lean heat. When you are presenting, one question is coming to mind because you're talking about very much about end-to-end optimization, end-to-end solutions, and that I do understand. If you come to a new district heating system and you can deliver the whole thing, the whole package. But what about all these utilities that has been up running for many years and have some of these partly from other vendors already? How is this able to interconnect with existing systems?
It's a good question, and that's also why open technology is important here. So it's not very, even though that are new utilities to be built, of course, existing utilities, they already have infrastructure in place, yeah. and we are software-wise and hardware-wise, we really do what we can to be compliant to open standards. So whatever exists in most cases, we will be capable of then attaching to that and put it on top of what's already existing. So we are not talking about a completely new investment for this. So this can be working finely in conjunction with existing systems solutions. Absolutely.
Right. Thank you. Lars, I think we go ahead with the next topic about how to gain operational and energy cost savings in the entire district energy value chain.
Yeah, will be 3 presenters, but I will start also this one. So lean heat production. So as we saw before, lean heat production is addressing the production side. So what is this really all about? And this is just a quick snapshot of what this is all about, but to get an idea of this end-to-end possibility. So part of lean heat production is actually to provide some load forecasting that can predict among other things, the heat consumption. Also, of course, production optimization on the production side, what can be done in order to have the most efficient economical setup. And also a part of this could be temperature optimization. So it's not that you have to take it all. You can actually pick from this what you want. You can have it all, or you can have it by modules. So if we dive a little more into it, we distinguish between, when we talk about this, what we say, the forecast part and the optimization part. And when we talk about forecast, we actually are talking about two things. There's a weather forecast, which is obviously important, and then there's a load forecast for the heat demand forecasting. On the production optimization, we are talking about how to get the optimal electricity production, how to secure peak boiler optimization, and also heat storage optimization. So that's a part of that. So also, of course, the whole electricity part is very important. On the temperature optimization, there's also a solution here where we obviously leverage the load forecasting information that we capture. And it's essentially about reducing the temperature on the supply side to minimize the cost of producing and transporting the energy. Very quickly, what does this mean to the people in the operation typically? First of all, the money to gain. So you can, if you can reduce the heat loss, you will save money. And if at the same time also you look into how to run it in the most economical way, that's basically what you want to achieve. You can perceive this somehow as a kind of CRM system of district energy, because basically what you do is that you leverage data that you in many cases already have, and you collect it and you have this holistic view, and by having it in one consolidated place, then you really can start to do the optimization. And while having all this information at hand, it actually also you will see that within the operation that you will get a deeper view, a more holistic view on how to drive your to operate in the most efficient way. So shortly, conceptual wise, what is production optimization as we view it? It means actually heat production, and it means electricity production scheduling. And this, of course, has to take into mind that at any time, of course, you should supply the heat that you should to your customers. So combined optimization of heat and electricity production, that is basically what we bring on the table here and called production optimization. I will quickly go to Lean Heat Network before I hand it over to my colleagues here. So Lean Heat Network is another module which is aimed at the distribution side. And Lean Heat Network is focusing on the design and planning part, but also the operation. And in a nutshell, it's about how you design your network, how you build and how you maintain your models. You can simulate hydraulic and thermal conditions in your network. You can optimize with this information, supply temperatures, pressure, etc. And with a load forecaster also, you can also predict. You can look into the future, if you will, to optimize your operation. Like I just showed for the linear production side, so a way to see it, We distinguish between what we call the offline part and the online/optimization part. On the online part, it's pretty much aimed for design and planning purposes. Often it's consulting engineers that are using a tool like this, but it can also, of course, be in-house in the utilities in the planning and design department. Then there's the online part, which is basically the offline part, but then added with SCADA data, and it's also a load forecast, and then you actually have a model where you can see actually what is happening here now in my network. And also on the optimizer side, there is both temperature optimization, as I also mentioned before, and there's also pressure optimization as an optimization. So what is this all about? This could be any city in the world, but this is simple of a real life city and associated network. And what we are doing with the Lean Heat Network, that is actually a digital twin, or how to translate this real world into a model which you can work on. And what we are doing is basically to take GIS data, and then you build a model. This is a very simplified way to show it, but of course you would have a heat plant or production site, you have some consumers, you have pipes, you have nodes, you have substation, you have a lot of data that you put into this to reflect the real world. And by doing so, you can start to calculate actually. And that are some of the things here. So what in terms of you will expand, refurbishments, new connection, etc. How should you actually design that to do it in the best possible way? You can have analysis of this. You can also use it for contingency plannings, etc. So basically, you have a lot of information stored in front of you that you have actually gathered from various systems. I mentioned this, that you can design the network, whether it's existing or new. You can calibrate it fairly easy in this, and you will also get some network layouts, etc. So it's very often used for feasibility studies, etc. So before you start the projects, you have done the pre-work in this. You can conduct what-if analysis. What happens? Are there any violations? Are there bottlenecks? Will a pump solve the problem, etc.? So you have all this at hand in this solution. So I know I have to speed up, Lars, so I will do it. So basically, the online part can do all the same as just mentioned, the offline part, but with the thing that it's actually also you're getting real-time data, typically from your SCADA data. So you can see what happens within your network here now, and with the load forecaster, you can actually also look 48 hours or something like that ahead to optimize how you're operating your system. Temperature optimization, very briefly, I can say we actually have two solutions we bring to the table. So we both have what we call a data-driven solution. So that is one way to do it. And we also have one which is based on the hydraulic. And both are pretty much doing the same. Different solution to different kind of needs and type of utility, but all in all, it's of course about optimizing the supply temperature and reduce the heat loss. That is typically where you can gain quite some savings. So with this, I would actually stop this quick, because we will also hear more from Fjernvarme Fyn and others, so it's more interesting to hear from the customer themselves. So I will then hand it over to you, Damien. So I will stop sharing my presentation now, and you can take it from here.
Yeah.
And Lars, in the meanwhile, there's been a question out in the chat.
Yes.
Maybe you can go out there and answer the questions there. And you're welcome to get on with the dialogue out there going on as we present here. Damien, go ahead.
Yeah, thank you for the word. Hopefully you can see my screen. Let me introduce the next tool. It's a Lean Heat Monitor. Okay, so what is a link heat monitor? It's one of the answers that to challenges that Lars mentions. So Lars mentioned 8 different challenges, and one of those was also legacy SCADA system. So link heat monitor is answer to that one. So it's a Danfoss software solution for monitoring and control of district energy systems. So it's a cloud-based software application. It's hosted in Microsoft Azure. This means that customer don't need its own IT infrastructure to hosting and running the application. Then if we compare it with traditional visualization, or how we call it usually SCADA systems, the biggest difference is that link heat monitor is designed and optimized for district energy systems. So we actually try to recognize the challenges, the workflows on daily work, and try to answer or solve the challenges here into link heat monitor as much as possible. Interaction with Danfoss controllers is very easy and automized more or less as much as possible. It supports third-party devices as well, but that requires much more manual work in connection and commissioning phase. Then why link heat monitor? Because it's open, connected, and transparent. It's a modern web-based cloud solution. It's customized for district energy systems and offer lower investment and predictable operating costs for the customers. Okay, let me explain one by one, a bit more into detail. Open, connected, and transparent. Connect with any device using standard communication in theory. That means that we can connect any device that using standard protocol. At the moment, Modbus RTU, Modbus TCP, and OPC server are supported. Actually, visualization commissioning for Danfoss devices is very easy, simple, and automized again as much as possible. But yeah, third-party devices requires much more manual work. So easy integration with business intelligence and optimization solutions. That means using the API that we offer, other applications can access the data that are collected in link heat monitor and can be further used for analysis, optimization, or billing purposes. So one of the purposes also optimization with link heat production, link heat network in online mode, like Lars mentioned already. So in an opposite way, also set points calculated in optimization tools can be written back into the controller. Then it's a part of district energy optimization suite together with link heat network, link heat production, and link heat building. Then modern web-based solution, it's always up to date. The latest version is automatically available for use. So since this is a cloud application, all newly released features are deployed and available for all the customers at once. So no local updates or special knowledge are needed. And there is also no special versions for any separate or specific customer. Then access from anywhere and from any device. It means that it's or as a web application that lives in Microsoft Azure, and all that user need to access it is a device like a desktop PC, laptop, mobile phone, tablet. So basically any device with a web browser or standard web browser. In case that user opens application on a small screen like mobile phone, this is automatically recognized and the mobile version of link heat monitor appear automatically. Then trusted security mechanisms for safe and secure data storage. That means whole communication between devices, cloud, client is secured, encrypted, and data are safely stored into Microsoft Azure. Then customized for district energy. So improve your work efficiency with functions like auto commissioning, group settings. So based on researches we did, we figure out what are the most common customers' workflows and what are their bigger pain points. So we consider that and try to help our customers with algorithms and workflows which are automated as much as possible. Then improve network control and management with actionable information insights. That means we included alarm notification, reporting functionality in order to keep users always up to date with the key information of the system, even if they are not sitting in front of the PC. So the standard approach is that operator is sitting in front of the PC. This is more or less history, and people would like to be notified wherever they are. So easy integration of new devices, once more, integration of new devices, especially Danfoss devices, is very quick and simple. That already Lars mentioned that in few clicks you can connect new device and get ready to use. So then lower investment and predictable operation cost. That means there is no need to buy a license. The customer just need to pay for the getting started package, which includes new customer connection, onboarding, initial devices commissioning, and training. Additionally, customer just need to pay fee per controller on monthly or yearly basis, so everything is predictable and without any hidden costs. Then reduced IT investment and maintenance cost. So customer don't need to buy hardware or specific server or dedicated PC to run application on it, since it's everything in the cloud. And also there's no need for special IT knowledge. Then unlock your resources to focus on primary business. By this, we means that customers can put a focus on their primary business instead of using a time for maintenance of monitoring and control systems. No need for backups, no need for operating systems upgrade, no need for application upgrade, and last but not the least, no need for hardware, server, or PC upgrade. With the cloud solution, we always try to ensure the best possible performance, redundancy, and security. And just quickly, the overview, link heat monitor around Europe at the moment. You can see here that we have 95 or even more already projects with more than 6,000 devices connected in total in 14 different countries at the moment. And that would be it from my side.
Thank you, Damian, and we will go directly continue with Lori. So you will end up on this and presentation here on the operational energy cost savings, and after that you present a live real life case based on the utility in Finland. Please go ahead, Lori.
Yes, I'll try to be quick. So my name is Lauri Hiekkanen, and I'm going to tell first about lean heat building and this Vatajankoski demand response end-to-end case. As Damian showed, we have this kind of offering that covers the whole value chain, and I think this lean heat building is the part where we are engaging the customer to the whole district heating system, so that we can enable control capability to the customer and secondary side, and then gain the data, and also we can utilize that data and flexibility when operating the network and optimizing the production. So this is kind of the key to add something new to the district heating system operation. Traditionally, there has been quite tight gap between the end customer or the after the substation and before the substation. And how does this work? Like traditionally, building heating control is based this kind of heating curve, outside temperature dependent, and maybe some manual tweaking that if somebody is complaining that it's cold. And it can provide maybe uneven indoor temperatures. Solar radiation can heat up apartments too much, and there's lots of waste of energy when working like that. And with lean heat control, we are tackling these problems. We are measuring the indoor temperatures. We are use weather forecasts, so we know beforehand when the sun is going to shine. And we build a model of the building thermodynamics and the resident behavior, like the hot water usage. So the model can then be like forecasting. We are forecasting a couple of days ahead, so we know how the building is going to be, in which state. And the model is all the time, like every hour, learning, updating the model. And,
Lauri, do you have a camera we could put on?
Don't I have it on? I should have.
Maybe it's just my screen that's frozen. Okay, go ahead.
Yeah. Yes. And of course, this lean heat control then can provide for the district heating system like capabilities like demand response or shaving the peaks, as we can optimize the consumption such way that we can smoothen it up. Here's kind of example how the control works. This is maybe a bit technical, but there's a kind of old control where the supply temperature on the secondary side is following pretty much the outdoor temperature. Then after this black vertical line, the lean heat control is the black line there that is trying to keep the indoor temperature stable. And then also we see that the indoor temperature has been a bit too high and fluctuating. So we can just set that the average indoor temperature is on a certain level, and then lean heat control keeps it on that level. And then, of course, lowering the temperature naturally saves some energy already, but then also the solar radiation effect is clear way also to save energy. And I think the second slide can show about the savings. So here we have like curve over like 100,000 apartments and how we have saved energy. Of course, there are some outliers where we are not saving energy, as if residents want to raise the apartment temperatures, for example, or some other outliers in the behavior, some renovation, etc. ongoing. But on average, we are saving 7% over our building stock. And the second part here shows quite clearly where the savings are coming. Like the savings are biggest during sunny spring days when we notice that there's solar radiation coming and we don't heat the apartments then, so the indoor temperature stays steady and we are saving the energy. I think the second kind of value proposition that we have is the peak shaving. On average, we see that we lower 20% of the peak power usage. And basically this figure illustrates it quite well, that there's this usual hot water usage peaks, mornings, afternoons, and we can then adjust the building heating such way that we can smoothen those peaks. And it provides quite a big advantage then to the district heating utility, for example, if there's a large penetration of lean heat sites on the network, that they don't have to use that much peak power. If we go one step further, then we can engage the customer, the demand side management, where the district heating utility can be the party controlling the peak power optimization, or utilize the buildings as a virtual heat storage even, which means that the optimization is given some indoor temperature band, like plus minus half degree, and then this is used to calculate then, based on our models, the capacities for the heat storage that then are then exposed to the district heating utility that can use that storage as well as conventional heat storage. And then there are maybe some example models how we can engage customers also to this kind of demand side management, seasonal energy pricing, peak power component in pricing, then reduction to heating prices, like when the production is CO2 neutral, kind of dynamic pricing. And of course, customers' big benefit is this kind of good indoor control comfort. They get more steadier indoor temperatures and also measurements to show the temperatures and actually also humidities inside. So I think that was lean heat building in a nutshell.
Thank you, Lauri. And you also, I think we just go ahead with the two cases. We have one here from Finland, and afterwards we have a case from Denmark. And as you all can see, the chat function is working. And please, if you have any questions during the presentation, just ask the questions out there, and we can handle it online also. So, Lauri, please go ahead with the first case here.
Yes, sure. So this is kind of real life case from Finland, Vatajankoski, and it's about combining heating demand response to production optimization. And we have there this lean heat production and also lean heat building at Vatajankoski utility area, or this Kankaanpää network. Pretty small place in Finland, but the local energy company is really innovative. They have been using our solution for this energy services, but also they have waste heat plant built there, and they have this kind of data heat also in some cases, warming up their swimming hall at Kankaanpää. So many things they have been trying. And their business is this kind of energy services for district heating customers, also construction maintenance services for networks and industry, electricity transmission, district heating and cooling. They sold the electricity retail business a couple of years ago. And it's originally built around local hydropower. Vatajankoski means this kind of hydropower site where it began. And their turnover is around 30 million. It's fairly small, though. You can see where it is in Finland. Somebody might say that it's middle of nowhere. Then what was the challenge? What we did at Kankaanpää? Like we have been Vatajankoski partner for this kind of building energy optimization and services since 2018, and at Kankaanpää there's a significant share of our solutions in their multifamily houses. And 2021 they invested to new waste heat plant, which will have a significant share of their heat energy production, and also in addition to that, large conventional heat storage, as the waste heat is available fairly steady level and only during weeks. It will be like the industry plant where it gets its heat, it will be shut down during weekends. So this new setup created clear need for optimization of the production, and they already had kind of bio CHP plants, was it 18 megawatts altogether, and oil and gas boilers. So with this combination, it's clear that you can optimize the electricity production and also electricity usage for the heat pumps in the waste heat plant. And I think it was quite natural to us to offer this for Vatajankoski, also because we had this kind of possibility for the demand response and connecting that to the production optimization. And what was the solution? At the beginning, we did kind of preliminary modeling and analysis of the network and this new production setup even before it was ready, like based on the figures they had at that time, and showed that, okay, it will be highly beneficial for them to start optimizing the production. And actually with current electricity prices and volatility, it has been even more beneficial than it was thought at the beginning. And then, as I mentioned, the demand side management was quite naturally integrated to that. And at the beginning, like in the initial state, Vatajankoski had been running mainly the CHP plant against the network, so they didn't need any forecast or optimization or anything. That was their main production asset that was running whatever the network required at the time, and some gas boilers mainly for the peak power. But then our goal was to create a precise load forecast for the network based on the historical data, then create a robust optimization model and integrate the demand flexibility to the production optimization to gain some additional advantage. And how did we do the implementation? Well, we had a kind of working group. They have fairly small organization, so like the same people were responsible for specifying and steering the project. But we first specified the commercial process, automation and integrations needed. I think the key topics were the value outcome, how it will be integrated to daily process, and of course the modeling quality that we can like provide consistent results from the optimization. And I think we already at the beginning we noticed that the auto integration to the automation system is the most critical technical part, and we collaborated quite closely also with the automation vendor to get that up and running. But still, I think that was one part that delayed our project a bit. And in addition, we need to, of course, integrate weather service, prices, and this lean heat building interface that we have there. And then if we look back for the implementation, I think lessons learned, we could have even more focus put on the daily process and also consulting Vatajankoski regarding that, as they hadn't had this kind of optimization solution before. Because of course, to get the value out of this kind of solution, you need to start using it. And if you are not using it, you don't get the value. You have to react to the schedules that the optimization provides. And then maybe when we started from the blank table, this project, we thought quite a lot about testing. Of course, my background is in bigger utility where you have already existing software, and this kind of project would be quite huge. But in the end, it turned out that it was better just to let the solution start running aside current operations and then tune the model when there's something that catches the eye of the operators, and then take it part by part into the operational process. Of course, if we would be replacing existing solution, then the focus would have been more like qualifying the optimization results against existing model and also fitting the whole solution to existing environment. Then about the outcomes, now solutions used by Vatajankoski operations, and the schedules are sent to the automation, and they have control room has views in the automation for the schedules. Those are not like connected to direct dispatching to the automation yet. And the schedules have been robust and consistent, like I would say almost half a year already. And we have done this kind of calculations, and of course with current electricity prices, it's quite obvious that in this case the value is quite high. Like payback time can be calculated in months. I don't know, haven't done any calculation on the highest electricity price peak that was in the December. Could be that a couple of that kind of weeks could provide payback for this kind of setup. So the project was fairly simple and worked quite well in Vatajankoski case. I think if I end now, we are almost in the schedule.
Yes, but I have there's one question in about what is the biggest network you have tested on and you worked with. There's a question from Tallinn where there's quite a big network with 450 kilometers of pipeline and 4,000 substations. So what is the biggest network? So you're talking about this is a depending on what country you're from, a small mid-size district heating system. What if you're in one of the bigger ones? What's the biggest ones you have implemented this system in?
Yeah, I think the biggest ones that we have are in Denmark. I don't know, do you, Lars, know, was it Aarhus or something like that? Size, like mid-sized city in Denmark.
Yeah, it depends on we're talking on the building side or the lean heat production. But lean heat production has been also used in parts of it in Aalborg. We are also doing it in a utility like Sønderborg in the southern part of Denmark. So a size like Tallinn, that should be absolutely fine. But we can get back to you, Vladislav, afterwards to discuss further details.
Yes. And another question I have, because when we're talking about storage facility, I mean, we have for many years have traditional heat storages. We have a tank or something like that. But you're also talking about some virtual heat stores. How is that? How do you compare these? Can you be without one and having not the other? And what is the value of that?
Yes, I would say like it's a bit different, but can be used same way, this virtual heat storage. Of course, it doesn't have that big energy capacity. I would say it's max 10 hours that if it's fully loaded and we can let the apartments to cool down like almost 1 degree, then it's something like 10 hours, the capacity. But if you combine all the like substation in a network, and typically with our parameters we get like 30% of the power capacity to be in use. That's quite huge power capacity that can be used from hour to hour.
So it gives some more flexibility into the system.
Yes, and of course lean heat setup gives some other benefits also than just like the heat storage. Like maybe if you would create this kind of heat storage, it's a bit more expensive than just putting the water tank. But that's just the one benefit of the lean heat building.
Okay, thank you so much, Lauri, for this showcase here. Now we'll jump on to the next live case we have from Odense. We have Per Andersen with us from Fjernvarme Fyn, one of the bigger Danish district heating utilities. Per, you have some considerations about online modeling.
Yes.
Please go ahead and
I'll share my screen.
Do it. Yes, please.
Can you see my screen now?
Yes, and then just make it full screen, and we're ready to go.
Okay.
Yes.
It should be. Yes. Okay.
Well, I think is it full screen now?
It's full screen on my.
Okay, it's fine. It is
Okay.
fine. Thank you.
Yes, I will start to say a little about our company, Fjernvarme Fyn. It's okay. I should just jump to the next. We are owned by the municipalities of Odense and North Funen, and we are the third largest supplier of district heating in Denmark. And we supply heat to the 200,000 citizens in the city of Odense, and also to a number of greenhouses around Odense. And we are almost 300 employees in the company. And we have a strategic goal to stop using coal actually this year, and also still be competitive on prices. And we also want to be climate neutral in 2030. Our company is divided into different subsidiaries where we carry out the different activities. We have one for our waste incineration, and one for our distribution, and one for the production. And then we have a service company where the employees they are employed. We have one of the largest district heating grids in the world. And we have more than about 67,000 meters and 120 kilometers of transmission lines and more than 2,000 kilometers of distribution lines. We supply heat from the central power plant to the distribution zones through 8 transmission lines. And in the distribution zones, we have peak load and reserve load boilers. And at the central power plant, we have a number of CHP units. The newest is straw-fired from 2009. And we have last year we installed flue gas condensation with the heat pumps to increase efficiency to a maximum. And we have a waste incineration. We burn nearly 300,000 tons of waste every year. And we have also carried out some projects on this facility where we have increased the efficiency to a maximum by installing heat pumps on cooling water and flue gas condensation and so on. And then the far largest unit is a coal-fired unit, and this, as I told you, we will stop using coal this year. And as a transitional solution, we are rebuilding it for natural gas, and we will use this the next until 2030. Then we're also building a new biomass-fired CHP, and we have installed 100 megawatt of electric boilers. Then we are planning a new. We already have an accumulator tank of nearly 65,000 cubic meter, but we are now planning a large pit storage just on the other side of this channel, where in the first phase we will build 700,000 cubic meter of storage, and then there's a second phase. So in total, it will be 1 million cubic meter. Then in recent years, we have built some decentralized heat pump stations. As you can see here, we have a heat pump plant at the Facebook data center, and one at the central wastewater treatment plant. And then you can also see here we have we are buying heat from a biogas plant south of Odense, and we also have a decentralized wood chip fired CHP. So we have several decentralized heat production facilities. Here it's a picture of the heat pump facility at Facebook, and this was commissioned in 2020. And you can see here from this picture you have the data center, and just on the other side of the road we built this heat pump facility where we recover the heat from cooling the data center. And in 2020 we installed 25 megawatt of heat pumps, and last year we further installed 20 megawatt, and now we are building 5 to 10 megawatt right now. And Facebook, they are planning to build 2 new data halls. So, and we are talking with them about recovering heat from these also. So it will be a fairly large plant. Then last year we also commissioned this new heat pump plant at the wastewater treatment plant, where we can produce nearly 20 megawatt of heat. You can see this here, and this is the wastewater treatment plant, and here's the heat pump facility, and then we connected it to an existing transmission line in the road. Then this is the biogas installation south of Odense, and then further we have several companies within the supply area where we recover heat from the surplus heat from their production. So this is the future concept for district heat production in Fjernvarme Fyn. We have several CHP units, central CHP units, and we have heat pumps, and we have electric boilers, and we have a lot of storage. And then we can produce electricity for the power market, and we can use electricity when the price is low, and yeah, we can operate this. And so the idea is to use electricity from the grid when the price is low, and use it for our heat pumps and boilers. And then when the price is high, then we can produce electricity and heat. And then if the price is moderate, you can say we can produce our own electricity on our CHP units and use it in our heat pumps and electric boilers. And this is, we have developed our own production planning system. And we can, every day, we participate in the electricity markets, and we plan the production and to meet the heat demand. And this is what you can see here. The heat demand is covered by these different production units, and then the line up here is the storage tank. So about our hydraulic modeling, we use hydraulic models for design of a network. The network when we expand to new areas, and we do renovation projects, and also for scenario, all kinds of scenario analysis. And then we are also able to connect these models to the SCADA system and run them online. And we use this for calibration and validation of the models, and also for analyzing operational problems in the network. And we have an old version of the Thermis software, and now we have We have bought the Danfoss Lean Heat network for design and online simulation, and we are in the process of implementation of this software. And here our challenges and problems we hope to solve with this software is that we have this growing complexity in the system due to the decentralized production units, and we have some we are challenged when we deliver the heat from these production facilities to the district heating network. This is causing some problems, I would say, and also we want to optimize the temperature, the flow temperature on the transmission lines, because as you know, the heat pumps, the lower the flow temperature, the more efficient they are. And in future, we also want to optimize our pump operation on the transmission lines and the temperature in the distribution networks. So these are the challenges and problems to be solved. And here you can see the picture from our SCADA system. One of our transmission lines where we have two production facilities. The one is the IP Mølle, where we recover heat from wastewater treatment plant, and the other is the wood chip fired CHP. And this is another picture of another transmission line where you have the heat recovery from Facebook and and we have the biogas plant where we also buy heat from this plant. So, and you can see, maybe you can see here the complexity of the system, and we have the power plant here, and then we have the different distribution zones along the line, and then on this production facilities in the system. This is just a picture from how we optimize the temperature in the distribution zones. We have installed shunt pumps. So finally, we hope to be able to use these online models for hydraulic simulation of the heat supply on the transmission lines and in the distribution networks, and also to simulate the operation in the near future based on load forecasts and production plans. And so we want to hopefully we can better plan the operation of the network and be able to avoid operational problems. And for instance, we can if we know how the network should be operated for the coming 24 hours, we know we can be proactive and change the valve positions in the network and be ready to change the set pump for pump operation. That's all from me.
Thank you so much, Per, also for showing how you are working on implementing Lean Heat network in your system in Fjernvarme Fyn, and how you use it in real life, and also that you having this increase in complexity in your system, making it necessary to have these systems. Now we move into the Q&A, and I already see a raised hand. I will ask you all to put on your cameras, and then it's more lively like we are together. So Gordon, you already did that, and please turn on your microphone and ask your question. We need your microphone on.
Now okay?
Yes, perfect.
Good. Yes, I am from the UK and therefore extremely impressed. Such a system is surely resilient and future-proof. So my question is, which of your many loads are direct coupled, let's say in the Danish style, without heat interface units? You understand the question, I'm sure?
Yeah, maybe.
Yes.
You mean if there are heat exchangers?
That's right. In particular, I'm hooking on to your mention of hydraulic analysis. And this is another criterion. I don't know the numbers, but you shouldn't exceed, what is it, 6 bar in the house or whatever?
Yeah. But we have in our system, I can say we have no heat exchangers. We have between the transmission system and the distribution system.
Yeah.
We have pressure reduction valves.
Yes, of course.
And have pumps.
Yes, but where sometimes they say in the Swedish style, you have heat interface units with plate heat exchangers, but in the Danish style, if you don't have many hills, then you can direct couple and save a delta T and so on.
Yeah, that's the way we do it.
Yeah, but I'm just picking up the point about it's another constraint. That because you can't put, I don't know, 10 bar or 30 bar into the house. Radiators.
No. That's why we separate we have this pressure separation of the transmission and distribution system by valve reduction valves and pumps.
Okay, I see. Yeah. Thank you.
Yeah. So even though it's a direct system you have in Odense, you have a reduction in the pressure.
Yeah.
For each distribution system.
Yes.
But the most systems in Denmark, I think, well, you have both, but I think the main part is with heat exchangers, I believe, in Denmark. But you have both. We have both systems in Denmark.
Yeah. Yes. Yeah. Thank you.
I can see there's quite a few people also from other utilities in different nations, and I'm wondering, is your complexity also increasing? I can see we have with us people from the Netherlands. We have already heard from Estonia. We have even from Canada. Are you also experiencing that you're getting more different sources into your heat delivery systems? So if you don't raise your hand in Gabriel, Mike, I will ask you directly, one of you later. But in the meantime, so please raise your hand if you have some comments on this. If we yes, okay, Arya, you're with us.
Yes.
I know you from earlier. Good to see you.
Okay. Hi. I have a question about the monitoring tool. Is that also possible? Do I have a question about that?
Yes, please go ahead.
I was wondering if in the monitoring tool itself, if it's possible for an end user to set up its own business rules based on the data. And second question is if it's possible to connect the monitoring tool to the if you have a ticket service, if it's possible to set up an API between the monitoring tool and the ticket service, so we can automate that.
Okay, let me answer. Of course, we have API, and basically all the data we are collecting in Lean Heat Monitor are available through the API. Is that the answer?
Because we already have an IoT platform on which the data is placed. What we're looking at is a monitoring tool to look at the data presented in the dashboards, but also connected to a ticket system, so that we don't have to do it all by hand. So we set up a set of business rules, and based on the business rules, we provide tickets for the ticket system and automate that. I was wondering if it's possible to do that with the monitoring tool of Danfoss.
Yeah, actually, it's not a part of Lean Heat Monitor. The ticketing system itself, the only thing you could get out of it are measurement data from devices like energy meters or controllers, and then based on those, you can do anything on top of it actually in a separate application, but that we would offering ticketing system, no, that's not.
No, I was not looking at the ticket system itself, because we already have that in place.
Yeah.
But more looking at the monitoring tool, if it's possible for an end user to how do you call it? Drag and drop to set up your own work stream and business rules, and based on the data and analysis done by the monitoring tool, it makes a ticket for the ticket system.
Mm-hmm. Yeah, but as I said, the only thing we could provide are data from devices connected, and that's actually it. There is no logic for creating such rules inside the system.
Okay, that's my answer. Thank you.
And I have another question here, because when we're talking about the production, and we're talking about more complex systems, where it's not only having one combining power, providing all the heat. You'll see steam turbines, you'll see electric boilers, heat storage, heat pumps, heat-only boilers, and so on. Are there any limits on your production from your system? Is there any limits on that?
Not many. So you mentioned a lot of the things that can be added. I think you also solar heating farms. I don't recall if you said, but that's also possible. So pretty much as long as you can obtain some data and have the relevant information, it can be used for lean heat production.
And regarding the, I think we went into the GIS systems, but I wonder if I don't know if we went into this, but on the monitor system, if it's possible also to put it on like a mobile app, so you can take it with you, and how does that work? And also thinking, and another question regarding the monitor, how do you actually handle different countries and different languages in your system?
Okay, let me start with mobile app. We don't have a separate or special mobile app. I mentioned during presentation that if you open it on a mobile phone, it's designed or adapted for mobile view. So it's automatically recognized and adapted to that small screen. Of course, on request, user can always switch to desktop option or desktop version, but yeah, it's a progressive web application. It behaves exactly as an app. You can put your shortcut icon on your phone and stuff like that. So yeah, and regarding languages and localization, yeah, the countries mentioned today, so those 14, we have translated application into local languages, of course, and whenever we step into the new market, we translate application to the new language. So.
And then regarding the buildings, I mean, we're talking about sensors. We need a lot of sensors to have all this information. I mean, if you go into apartments, how many sensors do you actually need in these apartments? Because there's quite a few if you have for each room, or how many sensors do you actually need in these buildings?
Yes, I can answer this. We have done many kinds of setups, but usually if we are having this kind of full lean heat building setup, then it's one sensor per apartment put in like a central location in the apartment. But we have also done some partial sensoring for the buildings when taking into account that I would say that at least 30% of the apartments need to be censored. And then we have also this kind of control model that is sensorless. We don't have to have any sensors, but we can still take into account, for example, solar radiation and the domestic hot water usage in the model. But of course, when we don't know about the conditions in the apartments, it's kind of statistical model regarding the indoor temperature, and then we are not getting as much energy or peak power savings because we don't know. We have to have some margin to the indoor conditions.
All right. I think we have been have a good introduction to what opportunities there are within lean and heat. We had we had 2 cases. We have learned that it can be fully system from production to network to monitoring to the building. We also learned that it can be connected with it's open source. We can be connected to any other types of existing software that utilities have. So I would say, well, go ahead and take hold of these guys you have presented here today, and they can inform you more. And then I will just say also, I didn't say that in the beginning, but this session has been recorded, so it will be placed on our webpage afterwards. And also you can find all the presentations if you want to make a more deep dive into what's been said, because some of the slides was presented quite fast. As always, we have a limit of time. So if you want to deep more into it, I think we will send you the ones who signed up here. We will send you a link so where you can find the presentation and the video, so you can deep more into it. And then you're of course always welcome to take hold of us here at DBDH or some of the presenters from Danfoss. Or from Fjernvarme Fyn, we had Per with us presenting. So I think we will end up the session here for today. It's 4:30 and right on time. So hope you will enjoy your late afternoon, and in the US, Canada, where you are, your morning. You're ready for your morning tea and coffee, and here we're ready for the almost we are ready for dinner tonight. So thank you for joining today. I have to mention one thing before you leave me. That is, we will have one more session taking place next Tuesday in a week from now. And I think I remember here. Yes, can you see my screen here? I believe you can. So the third webinar we have on next Tuesday is preparing utilities for a data-driven future. So have even more on data. So please keep following us. We'll be there with you next Tuesday. And I also have to make a little commercial here in the end. If you want to know more about district energy, please go into Hot Cool. That's the most spread out magazine within district energy globally. So please sign up. It's free. You can get it direct into your mailbox. And I think that'll be it. I will say goodbye and thank you for now.